We're going to create a spreadsheet that calculates how far a dropped object falls at a series of different times. Let's go ahead and put a label in here, and we'll call it object in free fall. Okay, just as a quick label. And now how far something falls when it's dropped depends on how strong gravity is. And so let's go ahead and we're going to put in a little label here. On the Earth, it's 9.8 meters per second is how fast gravity will cause an object in free fall to accelerate. We'll gain 9.8 meters per second in speed for every second it is falling. So the only real value or data here is 9.8. The G equals in this cell and the meters per second in cell C2, those are just labels to help us as humans understand what that data value in B2 represents. Now we're going to go ahead and we're going to put, well, it's time. I'm just going to call it T in seconds, and D for distance in meters. Now we'll start off with 0 seconds, 1 second, 2 seconds. We'll have it follow 1 second intervals, and I'll click and drag it down to 10 seconds. There we go. Now here we're going to put in the data column, we're going to put in a formula that will take the value of the time and the value of G and calculate how far that object has fallen in that time. Now the equation for the free fall distance, vertical distance an object falls, is 1/2 gt squared. I'm going to click in cell B5 right next to the time, and all formulas, to indicate that it's a formula instead of putting in data or text, starts with an equal sign. Equals 1/2 or 0.5 times G. Now G is B2, cell B2. Now I'm going to put it in like this, $B, $2. I'll explain the dollar signs in a minute. So there's our 1/2 G, G being B2, times, we're using asterisk for times, and the time here is A5. So we type in A5 times A5. Notice I'm not putting in the dollar signs, and hit enter. So in 0 seconds, this object has fallen 0 meters. Well, that kind of makes sense. But what I'm now going to do here is I'm going to click on this cell and I'm going to drag it down. I'm just going to drag it 1 just for the sake of showing you. Notice it is calculated and it's filled in 4.9 meters. In 1 second, an object falling on the Earth, where G is 9.8 meters per second squared, the object will fall 4.9 meters. If I drag down to the next, 19.6 meters is how far it'll fall 2 seconds from being dropped. Okay? Now let's talk about those dollar signs. Notice when I click in cell B6 that there's still B2 up in the formula bar. It's still referring to the value of G that I had put in cell B2. But notice that it's A6 here for the time. In other words, in this cell, it's not using A5 time t equals 0 seconds. It's using time t equals 1 second. In cell B7, for time 2 seconds, it's using A7. It's using the corresponding time next to the cell that has the formula in it. So what we're talking about here are the difference between relative references and absolute references. Without the dollar signs, that A6 here, or the A5 in B5, really says take the contents of the cell to the immediate left and multiply it by itself. That's the time squared, or t squared. So when I copied the formula downwards by selecting that cell and dragging the red box in the corner like that, it said, oh, it's a relative reference. It always wants to take the cell to the left and multiply it by itself. The cell to the left, taking it by itself, in this case A7. Whereas those dollar signs indicate, you know what, no matter where I copy that formula on the spreadsheet, the value I want to use is the value in B2, and only the value in B2. If I copy the formula somewhere else, it's not the one to the left, it's not the one 3 up and 1 to the right. It's always going to be cell B2, and that's called an absolute reference. So now, as I take this formula and I copy it down, we can see that at 6 seconds, an object dropped after 6 seconds has fallen 176 meters. The formula is 1/2 B2, which is our 9.8, times A11 times A11, 6 seconds squared. Now the advantage of this is now I can, on a whim, I can say, well, on the moon, where the force of gravity produces accelerations only 1.7 meters per second squared, I can change little g, and the values in the entire table update instantaneously. I'll switch it back to the Earth. So we can see that after 1 second on the Earth, a dropped object will fall 4.9 meters, whereas 1 second on the Moon, a dropped object will only drop less than 1 meter, 0.85. That's the power of a spreadsheet, in that you can change input data in formulas and have all the formulas instantly recalculate. Now last, one more quick trick here about absolute references. Looking at this formula, 1/2 times B2 times A6 times A6. That's not really very easy to understand for us humans. So I'm going to make it a little bit easier, at least, by taking that 9.8, the cell B2, I've selected it, and then up here where it says B2 in what's called the name box of Excel, I'm going to click there, and I'm going to type the letter G and hit enter. Now what I've done is I have given the cell B2, which is called B2, I've given it an alternate name, a nickname if you will. It's now called little g. So now I can go to here, and instead of $B, $2, I can put in the letter G. And I can copy that down here through the entire table. Notice that none of the numbers have changed because I'm still referring to that same cell B2, only I'm calling it little g. And so now the formula 1/2 g, well, that's a little bit more readable because g is our standard symbol for the acceleration due to gravity. We still have the A6 times the A6. I can't call that T because that's not a single value. It's a whole column of values. And so I can't call it T. But at least for this single value, rather than $B, $2, I can call it little g. And that makes my formula a little bit more readable for a human.